The examples in this video go with lesson 3.3, measures of position. Example 1. The table contains the final exam scores for 28 students in an elementary statistics class. Part A, find Q1. All right, our table is actually on the next slide. And Q1, remember, is the mean for the lower half of the data. Now, if we look at our table, our data has already been ordered in increasing order. And so we can see that our minimum point is 58, our maximum here is at 97. All right, so let's separate our data into halves because we need to find the median first, and then we'll be able to find Q1, which is the median of the lower half, and then Q3, which is the median of the upper half. Since there are 28 students, that means we're going to draw our line between the 14th and 15th data point. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So our median is going to be somewhere in between 76 and 76. Now, it didn't ask me this, but I can see that the median is going to be the average of these two because there's an even number of data points, and this is going to give me 76. All right, Q1 is actually going to come from this part of the data, the lower set. And it's just the median of this top row here. Well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 14. And half of 14 is 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So there are 7 data points on each side. That means Q1 is going to be the average between 69 and 71. And we have to average it because there are 14 data points up here on the top row. And this is going to give me 70. Part B is asking me to find Q3. So I'm going to do exactly the same thing, but I'm going to do it with the upper end of the data. So I'm looking at this end right here. And we're going to use all of this to find our Q3. Well, once again, we want to split the data in half, and that means our line is going to go right here between 82 and 84. This is where our Q3 is going to be located because there's an even number of data here. That means we're going to have to take the average. 82 plus 84 divided by 2, and this is going to give me 83 for my Q3. Part C, Fred got a 73 on the exam. What percentile is this score? All right, so Fred got a 73. That's going to be this point right here. All right, and to find the percentile, we are going to use the formula right here. We're going to multiply 100 times the number of values that are smaller than 73, and then add 0.5, and then divide that by the total number of values in our data set, which we already said was going to be 28. Okay, so the percentile is going to be equal to 100 times, let's see, how many numbers in our data set are less than 73? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. And then we're supposed to add 0.5. And then we're going to divide this by 28, which is the total number of data points. And when we put this in the calculator, I am getting 25.6, which is about the 26th percentile. Goodness gracious. Let's try that again. All right. Part D, students whose grades are in the 80th percentile or better will get a grade of an A. Now, Louisa got an 88. Does she get an A? So we need to figure out what grade corresponds to the 80th percentile. And we are going to use the formula right here. L is equal to P divided by 100 times N. So this is the position that the data point falls in our data set once it's in order. This is the percentile, in our case the 80th percentile, divided by 100 times the number of items in our data set. All right, so the position of the grade is equal to the 80th percentile divided by 100 times, and we said there are 28 numbers in our data set. And I am getting 22.4 here, but our directions had said that if the number we get is not a whole number, we're going to round it up to the next higher whole number. Now that's regardless of what the decimal is. So even though we've got 0.6, that would round up anyway, but if it had been 0.2, we would still be rounding it up to the next higher percent. So that means this one's going to be rounded up to the number that's in the 23rd position. All right, so we know this is number 14. Here's number 15, number 16, number 17, number 18, number 19, number 20, number 21, number 22, and here is number 23. So 86 is in position 23. And what that means is everybody who got an 86 or better is going to get an A on the test. So now we're going to go back to the question here. Louisa got an 88. Is she going to get an A? Yes, she will get her A. Louisa. All right, and here's our conclusion. Louisa will get an A because 88, which was her score, is greater than 86, which is the number that was in the 23rd position. Example 2. For the years 1869 to 2007, the 90th percentile of annual snowfall in Central Park in New York City was 50.1 inches. Approximately what percentage of years had snowfall less than 50.1 inches? All right, let's go back to our definition for what a percentile is. Our percentile, right here, separates the lowest percentage of data from the highest percentage of data. So whatever your percentile is, that's your lower percent of data, and then the higher percentage is going to be 100 minus that. All right, let's go back to our problem. Since we're looking at the 90th percentile, this means that 90% of our data is in the lower half, or the lower portion. And that means that 100 minus 90, or 10% of the data, is in the upper portion. Now let's answer our question. What percentage of years had snowfall less than 50.1 inches? That means we want the data that's in the lower portion, which means 90%. Example 3. The table shows the 2008 payrolls in millions of dollars for each of the 30 Major League Baseball teams. Part A, construct a 5-number summary. Our 5-number summary is going to consist of the minimum value in our data set, Q1, or the median of our lower half of the data set, the median of our data set, which is also known as Q2, and either one of those is acceptable, Q3, which is the median of our upper half of our data set, and the maximum, which is the largest number in our data set. All right, let's go back and look. The salaries have already been arranged for us, and they are in decreasing order. You can see going down from 209 to 81, and 79 here down to 22. So our minimum value can be found right here at 22. That is the lowest number in our data set. And our maximum value can be found right here at 209. That is the largest number in our data set. All right, now let's get the median first, because it's easier to find Q1 and Q3 if we know where Q2 is located. All right, so our median, let's see, we know there are 30 data points, and if we divide that in half, that's going to give me 15. So the median is going to be located between number 15 and number 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be in here in between 81 and this one right here, 79. The median will be located in here. Okay? So our median is going to be the average of 81 and 79. And that is going to give me 80. All right, Q1 is going to come from the lower part of the data set right here. So Q1 is going to be 15 divided by 2, because we want to find the one exactly in the middle. This is going to give me 7.5, and we're going to round that up to 8. So whichever one of these salaries is in the 8th position is the one that's going to be the median for my Q1. So 1, 2, 3, 4, 5, 6, 7, 8. That's this one right here, 66. And then for Q3, we're going to be looking here at the upper set of data. And Q3 can be found because we have 15 points on the upper end. We're going to divide that by 2. Again, this is going to give me 7.5. So whichever salary is in the 8th position up here is going to be my Q3. 1, 2, 3, 4, 5, 6, 7, 8. That's 119. All right, and this is my 5-number summary. Part B asks us to find the IQR. The IQR is just Q3 minus Q1. In our case, 119 minus 66. And that's going to give me 53. So our IQR is going to be 53. Part C, find the upper and lower outlier boundaries. All right, the lower outlier boundary is going to be our Q1 minus 1.5 times that IQR. Now in our case, Q1 is 66 minus 1.5 times that IQR we just found of 53. And that gives me negative 13.5. This means we don't have any lower outliers. And here's our conclusion. We know there's no lower outliers because the lower outlier boundary we got is less than our minimum value up here of 22. All right, let's find that upper outlier boundary. This is going to be our Q3 plus 1.5 times that IQR we found. Q3 is 119. And then we're going to have 1.5 times 53. And this is giving me 198.5. All right, we come back here. Anything that's in our data set that is more than 198.5 is going to be an upper outlier. And it looks like this guy right here, 209, is more than 198.5. That's going to be an upper outlier. My next number, 139, that's less than 198, so not an outlier. It looks like we have one upper outlier. All right, and here's our conclusion. 209 is an upper outlier because 209, that was in our data set, is more than the 198.5, which was our upper outlier boundary. Oh, and we just answered part D. The 209 was the outlier there. It is possible for a data set to have more than one outlier. If this one right here had been more than our upper outlier boundary of 198, we could have 2 outliers, we could have 3 outliers, we can have a lot of outliers. But in our case, we only had one of them that was more than our upper outlier boundary. We could also have upper and lower outliers, but again, in this case, we found that we didn't have any lower outliers because our lower outlier boundary was smaller than our minimum. Example 4, construct a box plot for the payroll data in the example 3 that we just did. All right, let's go back and remind us of our 5-number summary right here. The minimum 22, Q1 at 66, the median at 80, Q3 at 119, the maximum at 209. And we knew we had an outlier. That's important. And we had no lower outlier there. Okay, so let's figure out. We don't want to draw a number line and then just plot those points on it. We actually need to scale it. So let's figure out how we're going to scale it. I'm going to take my maximum. I'm going to subtract off my minimum here. This is going to give me 187. All right, now something that would be realistic to graph. I could let everything represent 10. I could, count by tens, and that's going to give me 20 little marks on here on my scale. So we can start down here at 20, then we have 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 210 right there. 20, 60, and this is going to be 100, 120, 140, 180, 200, All right, hang on, that's not right. I am going by 10s, not by 20s. Let's try that again. All right, there's 20, that's 30, that's 40, that's 50, there's 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, here's 200, and then 210 was this one back here at the back. Now, I did every other number so that my number line down here is not all bunched up with numbers. It'd be kind of difficult to read. Okay, the first thing we want to do is graph our median, which was 80. And 80 is located right here, and I'm just going to draw a little vertical line right there because we're going to draw the box first. Then we're going to draw Q1 and Q3. We're going to finish off the box. So Q1 is at 66. Right, here's 60. Here's 70. We'll just estimate 66 to be somewhere in here in between. And then Q3 is at 119. So that's almost 120, but not quite there. And now, if we just connect these lines, we've got our box, or our box and whisker plot drawn. Okay. Next thing we want to do is we're going to graph our minimum, which was at 22. So that's going to be a little bit more than 20. And that's just going to get a dot. And then we're going to graph our maximum, which was 209. So that's all the way out here. That's almost at 210. Okay. Our lower outlier boundary was negative 13.5. Negative 13.5 is somewhere way back here. So that means that 22 should actually be part of my graph. And so what I'm going to do is I'm going to connect my minimum to the box. All right. Our upper outlier boundary was at 198.5, so that's almost at 200. Now on here, that's going to put us about at this point right here. And anything beyond 198.5 is considered an outlier. Now what that means is, since this 209 is to the right or beyond the 198.5, I cannot connect the whisker to my outlier. So now I have to go back to my data set, and since I know this is an outlier, I go to the next highest data point that is not an outlier, and that's going to be the 139, and that one is the one that I'm going to graph on my box and whisker plot. So 139, not quite to 140, we're going to move to the left of it just a hair, and that's what we're going to connect our data point to. All right, so here we have an outlier. This is a data point. This is also the maximum, by the way. And this one is also a data point. And it's the minimum. Now, the minimum and maximum need to appear in your box plot, and they may or may not be outliers. But the important thing to know here is that your whiskers connect to definite data points in your data set, and they do not connect to the outliers.